If both compositions equal the identity function f of x equals x, then the functions are inverses. Okay, so we're going to do that f of g of x stuff that we did before, that composition, or g of f of x. Okay, so we're plugging in g of x for x and f of x. Okay, remember when we did that? Okay, that's what we're going to do here to check to see if these two functions they're giving us are inverses of each other. So what you'll end up seeing is if f and g are inverses, then once you do that composition, pay attention please. Once you do that composition, it will equal x. Okay? If you take g of f of x, it will also equal x. Okay, so you have to do both, reduce it, and see if it just ends up with an x value. Okay, so I want to go over some examples of that. So first one here, we have f of x equals 3x minus 3, and g of x equals 1/3 x plus 4. So first one I'm going to do is f of g of x. Okay? That's like saying I'm taking that g of x function and I'm going to plug it in for all of the x values in my f function. Okay? So, with my f function here, I start with a 3. So I can write 3. Then I have an x. I want to plug in g of x for that x value. So I'm plugging in 1/3 x plus 4. That was that x value there. Then I have to subtract 3. Okay, so here's your g of x function. I plugged it in for that x value there. From here I can just simplify. So I'm going to multiply 3, right, distribute into both those terms. When I do it with that first term, I end up with just x, right? 3 times 1/3 is 1. Okay, then 3 times 4 is 12, right? I'm distributing. And then I still have this minus 3. X plus what? 3 times 4 is 12. Oh, yeah, the end is x plus 9. That's what you're trying to get at. Yes. Yes, you're right. Yeah. Okay, so you end up with x plus 9 here. I still want you to check g of f of x. Okay, so that's the other way around. So you're taking your f of x function and plugging it in for the x's in the g function. Okay, so if I'm looking at my g of x function, I start with 1/3. Then I have that x value, which I want to replace with that f of x function. So plugging in 3x minus 3. Okay, that was the end of that x. Now I can add on 4 to finish off that g of x function. Okay, it's coming back to you when we did this before. Okay, again I can distribute this 1/3. So I have x minus 1 plus 4. So I have x plus 3. Now in both cases here, I did not just end up with x. Okay? If you end up with something like this, you can say these are not inverse functions. because f of g of x equals x plus 9, and g of f of x equals x plus 3. Okay, so these are not inverses of each other. Questions before I do the next example? All right, so looking at number 2. Looking at number 2, again, I'm given f of x and g of x. I need to find f of g and g of f. Okay, so same process here. I need to find f of g of x, which again, you're plugging in g of x in for your x's in that f function. Okay, so since I'm plugging into the f function, I need to look to that function. It starts with 2. Then we go to an x value here. I need to plug in what I have for g of x in for that x. So we have the square root of x plus 1 over 2 and that quantity. Now this x is squared. Don't forget to square that quantity. Okay? And then I have to still subtract 1, because that was in my f of x function here. Now, to simplify, if I square a square root, what happens?
Square root?
Yeah.
0.
It's not 0. But what else could you say? They cancel. So if I square a square root, those are going to cancel each other out. So I still have this 2 here. But now I can just write x plus 1 over 2. And then still subtract 1 at the end there. All right, so now I'm multiplying this quantity by 2. What happens to these two 2's? They cancel out. Okay, so I'm multiplying 2 by a half here. So I'm left with x plus 1 minus 1. So it would just be x. Okay, so that was f of g of x. Now I have to do the same thing with g of f of x. Okay. So I have g of f of x. So I'm plugging in f of x for the x's in my g function. Okay, so I'm looking at this one now. So I need that square root. I have this x here. I need to plug in what I have for my f. So I have 2x squared minus 1. Okay, that's that whole x right there. Then I need to add 1 to that and put it over 2. All right, so simplifying this. Looking at the numerator, I have 2x squared minus 1 plus 1. Those 1's will cancel. right? So I have 2x squared over 2. Okay, my 1's canceled. Now the 2's will cancel. Yep, they equal 1. So I have this square root of x squared. And again, those cancel. So it just equals x.
How did we get so...
How'd you get what? Not you. Okay.
Oh, this one's good.
So since both f of g and g of f reduce down to x, these are inverses. So these are inverse functions.
No more.
I'm going to write because, yep,
Because x equals x.
f of g of x equals x. Yes, and g of f of x equals x. Okay, so those ones are inverse functions. Questions on how I did either of these problems on the front? There is a backside, yep. Okay, then I want you guys to do number 3 on the back. You're going to do the same thing we did on these two problems. Find f of g of x and g of f of x.
Careful, don't hurt yourself. Don't whip me. Eric, I like the sock. Bert, was that you? Did you put the sock?
Yeah.
Oh, yeah.
Look on the ones like Sam.
I did. I won't be there. It's actually 6 hours.
Yeah, go Rick!
I'm not doing the class every day.
Give me like 20 minutes.
I'm glad that they don't have it anymore.
What do you want?
There's not anymore.
Guess what? I'm not gonna do that this time, okay?
Oh, yeah.
You don't even watch I left them to my watch. Oh, that sucks.
Give it a try. Just hold on. Hold on. Don't get so. Don't hustle around. Try. You got Nick ready. Now I tried to send it right. 40 bucks.
Yeah, I started right.
Yeah, just like. You mean like the part where you like stop? Like you kind of like half stop? Yeah, you may not be 4 times 2 is 8. You try to take by 8.
Come on.
I have a question. Come on, Matt. You know, I went to work today. I used Matt. I said there's one.
Yeah, I think he meant to look
Seven.
very.
Okay, seven. Like right number seven.
Square first. So you have to square both your terms first. And then
I got you. One, two, three.
Oh, really?
How about we do 4x? Dude, Eric, shut up.
Oh.
You know what I do when I see that? Someone else gotta do it now. 4x.
I would.
You the group that shit. Squared? No. Go back.
Yeah.
Now we take more. Is it 16x?
the first one, yeah.
Good, yeah, lick my left and right.
Hey,
Good one.
stop. Stop. Now.
I didn't say anything, so you can't stare at me.
I know. Sam, go back to your own table now.
Oh, really? You think that's how this works?
Yes, I do. Go back to your own table.
I actually got it done. The first one. They probably have
I got a question. Would be like after you put like the next one, would it be sports in here?
Wait. Ooh, that was watermelon. Yeah. It's bald. What?
All right, I'm going to start going through number 3.
No, Tegan. Sorry. Almost 7.
Let's quiet down now, please. Hey, talking, stops. Guys. Hey, can we stop talking? Yeah? Okay. All right, so first we're finding f of g of x. Okay, so I'm plugging in g for all the x values in f. So f of x here starts with 4. Now I have this x value. I need to plug in g of x for that x value.
Yeah, we do.
Okay, so I have 2 square root of x. And then that is squared. Now that square, you have to distribute to both of those terms. Okay, so I still have this 4 times 2 squared is 4. And the square root of x squared is x. And you get 16x. Okay, I still want to check g of f of x. Okay, so I'm plugging in f of x for g. Okay, so here's my g of x function. I have 2 times the square root.
Oh, I get it.
And I'm plugging in 4x squared.
But now you square the x and the 4.
Quiet, please. I can take the square root of both of these terms. Okay? So I have the square root of 4 is 2. And the square root of x squared is x. So I end up with 4x. Okay, so these are not inverse functions. Because f of g of x is equal to 16x. And no, g of f of x equals 4x. You might want to in your notes just so you have a reference back to it.
So is that a whole or is that multiplication?
It's an open circle symbol.
Oh. So like an O.
It's not going to look like an O when you see it on your paper, though. It might look like an O when I draw it, just because I draw it too big. But
Well, I mean, fog. If it's an open hole.
it is open, and you'll be able to see it.
So it's like a donut?
So,
All right, I'm done
so
now.
what you're saying is like a...
Stop. You need to stop. Questions on number 3? Yes. All right, so number 4, we're doing the same thing. Yep. So f of g of x. Plugging in g of x for the x in f of x. We have 2. Square root. Now I'm plugging in my g of x function here. So we have 1/4 x squared plus 5 minus 5. From here I want to simplify. So I have this plus 5 and minus 5. Those will cancel out. So I have 2 times the square root of 1/4 x squared. Now I can look at this as 2 times the square root of 1/4 times the square root of x squared. Okay, that's what I did with that square root of 4x squared before. This time I'll just split it up for you. Now when I have the square root of 1/4, I can take the square root of 1. That's 1. And I can take the square root of 4. That's 2.
Whoa!
Okay, so once I take this square root, I end up with 1/2. Once I take the square root of this x squared, you just get x. Now if I have 2 times 1/2, that equals 1.
1 times x equals x. Whoa.
Okay, so this one will equal x.
Yeah, it will.
Next I need g of f of x.
Yeah.
So we're plugging in f of x for g. So I have to look at that g of x function. So I start with 1/4. Then I have this x. I need to plug in that whole equation. So we have 2 square root x minus 5. Then that x was squared, so I need to square it. And then add 5.
Yeah, so you do your exponent, and you're just going to get 2x.
So I'm going to square both of these terms. Okay, so I need to square this 2. I get 4. I need to square this square root here. They cancel. Okay, so I still have that x minus 5.
Yep. Yeah,
plus 5.
There you go.
Now all 3 of these are multiplied together.
Yeah.
So if I take 1/4 times 4
Equals 1.
equals 1. So I end up with x minus 5 plus 5.
Yeah, and both your 5s cancel, so it's X.
So
No
it's
way.
good. It's golden.
That's pretty awesome.
Okay, so these are inverse functions. I'm not going to write the other part.
Mm-hmm.
It's okay. Yep.
No.
No, on your assignment, it'll just ask you to say yes or no, if they are or not. How much time do we have left? 10 minutes?
10 minutes.
Yeah.
So I leave.
The class. Oh yeah. We're gonna skip this one because this is the one we did yesterday.
Mm.